Good morning, students. In our previous discussion, we had discussed about preparation of alcohols. We have seen various methods and reactions related to preparation of alcohols. So, after the preparation of alcohols, we will see a few reactions which will tell us about the chemical properties of the alcohols. As far as physical property of the alcohol is concerned, you know that alcohol contains OH group. As a result, it can form hydrogen bond with water. As a result of which, it is soluble in water. Now, lower alcohols, the alcohols which has got smaller chain of the oily or fatty hydrocarbon, long chain hydrocarbon, they are insoluble. Okay, higher alcohols are insoluble. Also, the alcohols which has more than one OH group, they undergo intramolecular hydrogen bonding. As a result, their solubility is also less in water as compared to monohydric alcohols. Monohydric alcohols are the alcohols which contains only one OH group. Polyhydric alcohols are the alcohols which contains more than one alcohol, like glycerol. In glycerol, there are three OH groups. It is like 1, 2, 3. Okay, so in three carbon atoms there are three OH groups. As a result, they form more of intramolecular hydrogen bonding. As a result, the hydrogen and the oxygen atoms are less available for forming hydrogen bond with the solvent, that is water, and hence they are less soluble. You will find that glycerol is viscous in nature. Okay, and other alcohols, they are less viscous and they are volatile in nature. That means they absorb heat from the atmosphere and they can convert themselves into vapors. Their boiling points are low. Whose boiling points are low? The alcohols whose carbon chain or hydrocarbon chain part is shorter and number of OH groups are lesser. They form intermolecular hydrogen bonding. Okay, and these intermolecular hydrogen bonding are weak hydrogen bondings and they are volatile in nature. So these are the physical properties. Okay, they are soluble in water, but if it is higher alcohol, means higher alcohol in the sense, if the carbon chain is long, then they will have the oily part more. As a result, they will be less soluble. All right, so these are the physical properties. So we'll see a few chemical properties of alcohol. So whenever we talk about properties in chemistry, we generally talk about chemical properties. Properties of alcohol. If I write any alkyl group as R, O, H, then it can show a reaction in which cleavage of OH bond can take place or cleavage of RO bond can take place. Alright. So we'll see a few reactions in which OH bond will break and a few reactions in which RO bond will break. Let us see. Say, if I write R, OH and treat this with sulfonyl chloride, then it will form RCl. This we had seen earlier. Okay. If we heat it at 414 Kelvin, then they will form ether. They will undergo dehydration and they will form ether. But if we heat it at 443 Kelvin in presence of acid like H2SO4, it acts as a dehydrating agent. H2SO4 acts as a dehydrating agent. So it will form alkene. Now I cannot write any specific alkene because I have taken general alkyl group. Say if I write here CH3 CH2OH for this, then I would write here CH2 double bond CH2, and for this we will write CH3 OCH3. Okay, so in this we are seeing that in the first reaction what is happening, the RO bond is breaking. In the second reaction we are seeing that OH bond is breaking. if we treat it with sodium metal, then we can show the acidic property of this H plus. Okay, it can show acidic property also. Not as acidic as the mineral acids or the organic acids are, but are acidic in nature in the sense that they give out hydrogen atoms. So it can form ROH, will form RO minus Na plus, and hydrogen gas will come out, and we can balance it. If you treat this with carboxylic acid like CH3 COOH, then it will form ester. It will undergo esterification. This you had seen in class 10 also. So this will form CH3 COOR. So here this hydrogen, because it is more acidic, and this OH comes out and forms water. What else can we do? We can make it to react with Grignard reagent. Say for example, if I ask it to, or if I make it to react with Grignard reagent, say CH3MgBr, then it will form, this hydrogen will go and attach with this methyl group and will form methane, and will form Mg ionic bond with OR, okay, and another ionic bond with OH. So this reaction is also used for finding out number of hydrogen atoms in the alcohols or number of alcoholic groups. This type of reaction is used for Zere-Wittenhoff's determination of hydrogen. What if we reduce it, and what if we oxidize it? Now here we will require to take specific example. So we can take this as specific molecule. If you reduce it with lithium aluminum hydride, this is a very common reducing agent which we have to remember. It will form ethane back. If we oxidize this with KMnO4, it will form CH3 CHO aldehyde. Further with KMnO4, this can form acid also. And you know that KMnO4 acts as a oxidizing agent in basic medium. So you have to give a basic medium here. So it will form CH3 COOH. Alright. This can also form halide with PCl5. It can form CH3 CH2 Cl. Okay. Now we can name these reactions also. What is happening here? Here substitution reaction is taking place. Here dehydration is taking place. What kind of dehydration? This is not complete dehydration. It is partial dehydration, or we can say mild dehydration, because heat is less. And this is a strong dehydration. Now you will say that in organic chemistry we said that there are 5 types of reaction. So why these many names are originating? So this dehydration is nothing but elimination of OH and H to form water. So elimination of H plus and OH minus to form water is dehydration. So dehydration is nothing but a kind of elimination reaction only. Alright, it is esterification reaction which we know already. Now this is a reaction with the Grignard reagent, and as much of methane will be formed. The volume of this methane can be found by downward displacement of water. Okay, and by the displacement of water we can find out how much of volume of methane is collected, and with that volume, using stoichiometric relation and mole concept, we can find out how many hydrogen atoms are there, and as many hydrogen atoms are there, that many alcoholic groups are also there. In this way we can find out the number of hydrogen atoms. It is called as Zerevitnav's determination of hydrogen. Alright, this was about properties of alcohol. Now next we have to study about preparation of phenol and the properties of phenol. So in our next video I will put that up, because in one video it will become little confusing. So for one small important topic I will make only one small video, so that you can refer to the topics section by section. Okay, thank you.